This code imports the necessary libraries for stock prediction such as NumPy, Pandas, Matplotlib, and Seaborn. It then sets the Seaborn theme and enables inline plotting. This code imports a module called datetime, which is used to work with dates and times in Python. It is likely that this module will be used to perform some time-based calculations or operations in the stock prediction program. This code reads a CSV file containing stock data from a specific location on the computer. The file is then stored in a data frame object called df. This code is used to display the first few rows of a data frame called df. The df.head function is used to access the first few rows of the data frame. By calling this function, the code displays the top 5 rows of the data frame. The code is accessing the shape attribute of a data frame object named df. The shape attribute returns a tuple that represents the dimensions of the data frame, with the first element representing the number of rows and the second element representing the number of columns. This code is a part of a stock prediction program. It takes the time column from a dataset named df and converts the data into a datetime format using the pd.to_datetime function. This code adds 4 new columns to a data frame called df. The first column is called year and it contains the year of the dates stored in the time column. The second column is called month and it contains the month of the dates. The third column is called day and it contains the day of the dates. The fourth column is called day_of_week and it contains the weekday of the dates. 0 represents Monday, 1 represents Tuesday, and so on. This code is a part of a stock prediction program. It adds a new column named week to a data frame called df and initializes all its values to 0. Then, a loop is executed 998 times, where the current index I is used to access and assign a value to the week column in df. The value is obtained by getting the ISO week number from a date calculated using the year, month, and day columns in df. This code is used to display the first few rows of a data frame. The data frame is likely to contain stock market data, as mentioned in the context of stock prediction. The df.head function is a command that lets us see the top rows of the data frame in a tabular format. By looking at these rows, we can get a quick glimpse of the data and understand its structure and contents. This code is assigning the values in the time column of a data frame, df, to be the new index of the data frame. This code removes 3 columns, namely row index, time, and test return, from a data frame named df. This code is used to display the first few rows of a data frame. The df.head function is called on a data frame object, denoted as df. It retrieves and shows the first few rows of the data frame. This is often done to quickly get a sense of what the data looks like and to check if it has been loaded correctly. This code performs an operation on a data frame called df. It checks for any missing or null values in the data frame and calculates the sum of null values for each column. This code removes any rows with missing values from the data frame called df. This code is checking the shape of a data frame called df. The shape of a data frame refers to the number of rows and columns it has. By checking the shape, we can find out how many data points and features are present in the data frame. This code is for stock prediction. It divides the dataset into 3 parts: training, validation, and testing. The training data includes the first 800 rows of the dataset, the validation data includes rows 801 to 905, and the testing data includes all the rows starting from row 906. This code is part of a stock prediction program. It is used to split the data into input features, train_x, val_x, test_x, and corresponding output values, train_y, val_y, test_y. The train return column is removed from the input data and stored separately as the output values. The code train_y.tail retrieves the last few rows of the train_y dataset. It is likely used to check the values of the target variable in the training set, which is typically used for forecasting or predicting stock prices. The tail function is commonly used in programming to display the last few elements of a dataset or list. This code is related to stock prediction. The function val.tail is called, which is likely a function in a programming language. It is used to retrieve the last few records of a dataset called val. By using this function, we can see the most recent data points in the dataset. The purpose of this is to analyze the recent trends and patterns in stock prices or other financial data. This code is accessing a method called head from an object called test. The head method is used to display the first few rows of a dataset. This code creates a figure with a size of 40 by 10. It then plots the data from the train return column of the trained dataset, which seems to be related to stock returns. This code is used for stock prediction. It creates a figure with a size of 40 by 10 units. The trained dataset is grouped by year, month, and week, and the sum of train return values is plotted on the graph. The resulting graph shows the total returns of the training data over time, grouped by year, month, and week. This code is a part of stock prediction. It creates a figure with a size of 10 by 10. Then it groups the values by year, month, and week, and calculates the sum of the train return column for each group. Finally, it plots the sum of train return values over time. This code is related to stock prediction. It uses the train data frame to group the data by year, month, and week. It then calculates the sum of the by_i_volume column for each group. Finally, it plots the resulting values using a line graph. The plt.figure fig size equals 40,20 line sets the size of the graph. This code is used for stock prediction. It creates a figure with a specific size of 60 by 20. Then, it groups the by_n_volume data from the trained dataset by year, month, and week, and calculates the sum of the volumes. Finally, it plots this sum on a graph. This code is used for stock prediction. It creates a figure with a size of 40 by 20. The trained dataset is grouped by the year, month, and week columns, and the sum of the by_account_cliente column for each group is then plotted. This code first creates a figure object using the plt.figure function and sets the size of the figure to 40 by 20. Then, it groups the by_account_client column in the trained data frame by the year, month, and week, and calculates the sum of the values in each group with the .sum function. Finally, it plots the resulting data in a line graph using the .plot function. This code is related to stock prediction. It first imports the necessary library called matplotlib.pyplot as PLT. Then it creates a figure object using the plt.figure function and sets its size to be 40 inches by 20 inches using the fig size parameter. After that, it groups the cell_i_volume column of a data frame called train by year, month, and week. It then calculates the sum of the grouped volumes using the sum function and plots the result using the plot function. This code is used for stock prediction. It first sets the figure size for the plot as 40 by 20. Then it groups the cell_n_volume column in the trained dataset by year, month, and week. It calculates the sum of the cell_n_volume for each group. Finally, it plots the sum of the cell_n_volume against the grouped year, month, and week data. This code creates a line graph to visualize the sum of sales for a specific category, cell_account_cliente, over time. The data is grouped by year, month, and week, which allows for a more detailed representation of sales trends. The graph is plotted using the matplotlib.pyplot library, with the figure size set to 40 by 20. The resulting graph provides an easy-to-understand visual representation of the sales performance over time. This code creates a large figure for visualizing stock prediction data. It groups the data by year, month, and week, and then sums up the number of sells made by clients in each group. Finally, it plots the sum cell counts on the graph. This code is plotting 4 different charts related to stock prediction. The first part of the code sets up the layout of the charts, creating a subplot with 2 rows and 2 columns. Then, it adjusts the size of the figure. The next 4 lines of code plot different data on each of the 4 subplots. The train_x data frame is grouped by year, month, and week, and the sum of the volume of different types of purchases and sales is plotted on each subplot. Finally, some adjustments are made to the layout of the subplots, and titles are added to each of the 4 subplots. This code snippet is from a stock prediction program. The line train_x.head is used to display the first few rows of the train_x dataset. It is a way of inspecting the data and understanding its structure before performing any analysis or modeling. This code imports the min-max scalar class from the sclearn.preprocessing library. It then creates an instance of the min-max scalar class called sc_out with a feature range from 0 to 1. This code is normalizing the volume data for buying and selling stocks. It uses the sc_out object to perform the normalization. The code first applies the normalization to the volume data on the training set, train_x, then on the validation set, val_x, and finally on the test set, test_x. It specifically normalizes the volume data for buying stocks with individual investors, buy_i_volume, buying stocks with non-individual investors, buy_n_volume, selling stocks with individual investors, sell_i_volume, and selling stocks with non-individual investors, sell_n_volume. This code is part of a stock prediction program. It removes certain columns from the data frames train_x, val_x, and test_x. The columns being removed are year, month, day, day_of_week, and week. The code uses the drop method with the axis parameter set to 1, which means it is dropping columns, and in place set to true, which means the changes are made directly to the data frames without creating a new copy. The code is calling the head function on the variable val_x. This function returns the first few rows of data from the variable val_x. This code imports the TensorFlow library, which is used for implementing and training machine learning models. TensorFlow is commonly used in stock prediction tasks to build and train neural networks. This code is using a callback function called early stopping from the TensorFlow library to monitor the validation loss in a stock prediction model. It will stop the training process if the validation loss starts increasing, indicating that the model is no longer improving. The arguments provided to the early stopping function specify that it needs to monitor the validation loss, the mode should be set to min to find the minimum value, and it should provide verbose output. This code defines a sequential model for stock prediction using TensorFlow. The model consists of multiple dense layers with different numbers of units and activation functions. The layers use the rectified linear unit, ReLU, activation function, except for the last layer which has no activation function. The model is compiled with the mean squared error, MSE, loss function, which is commonly used for regression problems like stock prediction. The atom optimizer is used to optimize the model's parameters. The model is also configured to track the mean squared error metric during training. The model is then trained using the fit function. It takes in the training data, train_x and train_y, as well as the validation data, val_x and val_y. The model is trained for 1000 epochs, and the training progress is displayed with a verbosity level of 1. This code predicts the value of stocks using a model. It takes the input data, which is stored in the variable val_x, and passes it through the model. The predicted stock values are then stored in the variable val_prediction. This code first calculates and prints the mean absolute error between the actual stock prices, val_y, and the predicted stock prices, val_prediction. The mean absolute error is a measure of the average difference between the actual and predicted values. Next, it calculates and prints the mean squared error between the actual stock prices, val_y, and the predicted stock prices, val_prediction. The mean squared error is another measure of the average difference between the actual and predicted values, but it places more emphasis on larger errors. This code imports the random forest regressor class from the Sklearn.ensemble module. It then creates an instance of the random forest regressor class called regr, specifying some parameters such as a maximum depth of 200, a criterion of squared_error, and 200 estimators. Finally, it fits the random forest regressor model to the training data train_x and train_y. This code is a part of a stock prediction program. The regr.score train_x, train_y line is calculating the score of the prediction model using the training data. The regr object is the prediction model that has been trained on the train_x data, features, and train_y data, target values. The score function calculates the accuracy of the model's predictions by comparing them to the actual target values. In this code, the variable val_pre is being assigned the result of a prediction made by a machine learning model called regr on some input data called val_x. This prediction is related to stock prices and is likely part of a larger stock prediction algorithm. This code is selecting the first 10 values from the variable val_pre. The purpose of this code is not clear without additional context as it only selects a subset of values from the variable. This code imports two functions, mean_squared_error and mean_absolute_error, from the Sklearn.metrics module. These functions are used to calculate the mean squared error and mean absolute error, respectively. The code then uses these functions to calculate the mean squared error and mean absolute error between two sets of values, val_y and val_pre. The resulting errors are then printed to the console. This code adds a new column called test return to a data frame called df and initializes it with the value of 0. This code is used for stock prediction. It uses a machine learning model to make predictions on stock data. The code takes in 3 sets of data: train_x, val_x, and test_x. It then uses the rigor model to predict the stock returns for each set of data separately. The first set of predictions is stored in first_return, the second set is stored in second_return, and the third set is stored in third_return. The code you provided is asking for the shape of the variable first_return. The term shape in this context refers to the dimensions or structure of the variable. By calling shape on the variable, the code is asking to see how many rows and columns are in the first_return variable. This code updates a column called test return in a data frame called df. It assigns values to the first 800 rows of the test return column by using a variable called first_return. Then it assigns values to the rows 801 to 905 by using a variable called second_return. Finally, it assigns values to the remaining rows, 906 and onwards, by using a variable called third_return. This code is likely used in a stock prediction system to update the test return values for analysis or modeling. This code retrieves the test return column from the data frame df. The column likely contains the test return values for a stock prediction model. This code saves a data frame, df, as a CSV file named df2.csv in the specified directory /user/rasid qualifying task /source /data /edited. The index equals false part ensures that the index column is not included in the CSV file. This code imports the necessary module statsmodels.api, which is used for statistical modeling. It then applies the seasonal decomposition function from the module to the train return column of the train data, using the add model in a period of 52. The seasonal decomposition function helps to separate the time series data into its trend, seasonal, and residual components. This code is used for plotting a graph related to stock prediction. The graph is likely to show the fluctuation in the value of a particular stock over a period of time. The code first plots the graph using the cs_d.plot function. Then, it sets the height and width of the figure using the fig.set_figheight and fig.set_figwidth functions. Finally, it adjusts the height of the figure again using fig.set_figheight and displays the graph using plt.show. The code is responsible for plotting a seasonal trend of stock prices for a specific time period. The figure size is set to 40 units in width and 10 units in height. The data being plotted is the seasonal component of stock prices, specifically for the period from September 2018 to September 2020. This code plots the residuals of a stock prediction model between the years 2018 and 2020. The plt.figure fig size equals 40,10 line sets the size of the figure that will be created for the plot. The cs_d.resid 2018-09:2020-09 selects only the residuals between September 2018 and September 2020 from the dataset. Finally, the plot function is called on the selected data to display the plot. This code defines a function called test_adf that takes in a series of data and an optional title. It uses the add fuller function from the stats models library to perform an augmented Dickey-Fuller test on the input series. The augmented Dickey-Fuller test is a statistical test used to determine if a time series is stationary or not. Stationarity is an important concept in time series analysis, where a stationary series has consistent mean, variance, and autocorrelation over time. Inside the function, the code generates a dictionary called fout to store the critical values from the Dickey-Fuller test. It then checks if the p-value from the test is less than or equal to 0.05. If the p-value is less than or equal to 0.05, the code prints statements indicating that there is strong evidence against the null hypothesis, which suggests that the data is stationary. It also prints the title of the dataset. If the p-value is greater than 0.05, the code prints statements indicating that there is strong evidence for the null hypothesis, which suggests that the data is not stationary. Again, it also prints the title of the dataset. Essentially, this code is a utility function that performs an augmented Dickey-Fuller test on a given series of data and prints whether the data is stationary or not. This code is part of a stock prediction program. It is calling a function called test_adv and passing in the train return data from a variable called train. It is also passing in a string called train return. The purpose of this code is to test the data for stationarity, which is important for predicting future stock returns. This code is a part of a stock prediction program. It imports the function autocorrelation_plot from the pandas.plotting module and the pyplot module from the matplotlib library. Then, a figure is created with a size of 10 by 10. The autocorrelation_plot function is called on the train return column of the train data frame. Finally, the plot is displayed using pyplot.show. This code creates two subplots, each with a size of 10 by 5. The first subplot displays the autocorrelation function, plot for the data stored in the variable train_y with a maximum lag of 8. The second subplot displays the partial autocorrelation function, plot for the same data with the same maximum lag. Finally, the plots are displayed using plt.show. This code imports the pndorima library and the function auto_arima from the pndorima.arima module. It then uses the auto_arima function to perform an automatic selection of arima model parameters for time series forecasting. The function takes the train_y variable as the target variable and the train_x variable as the exogenous variable. It sets various parameters such as the starting values for p, q, and d, the maximum values for p, q, and d, and other options like trace, error action, and warning suppression. Finally, it assigns the result of the arima model selection to the variable step_ys. The code is calling a method called summary on an object called step_ys. This method is likely implemented as part of a stock prediction algorithm. The purpose of calling summary is to generate a summary of the results or information obtained during the stock prediction process. This summary will provide a brief overview or analysis of the predictions made. To understand the exact details of what the summary method does and what information it provides, you would need to refer to the documentation or implementation of the step_ys object and the corresponding method. This code is related to stock prediction. It uses the arima model from the stats models library. The train_y variable contains the historical stock prices and the train_x variable contains any additional information or features that are used in the prediction. The order parameter specifies the order of the R, I, and MA components of the arima model. In this case, the order is set to 4, 1, 0, which means there are 4 lag observations, 1 differencing, and 0 moving average terms. The model is then fitted to the data using the fit method, and the resulting model_fit object can be used to make predictions. This code takes a trained model and uses it to make predictions for a specific period of time. The predictions are made for the data in the validation set. The start and end points for making predictions are determined based on the length of the training and validation sets. The predicted values are stored in the variable called predictions. This code retrieves the values of the predictions made by a stock prediction model. It does not perform any calculations or make any modifications to the data. It simply returns the values of the predictions as they are in the code. This code defines a variable called val_y. It does not contain any assigned value or any operations. This code creates an empty data frame called act with two columns named actual and prediction. It seems to be used for storing actual values and predictions related to stock prices. This code is related to stock prediction. It assigns the values from val_y to a column called actual in the act variable. It also assigns the values from predictions.values to a column called prediction in the same act variable. This code is related to stock prediction. The act.head function is used to display the first few rows of the act dataset. By calling this function, the code will output a summary or preview of the data. This code is displaying a graph of actual stock prices and predicted stock prices. The actual stock prices are plotted with a blue line, while the predicted stock prices are plotted with a red line. The graph is displayed with a size of 20 by 8 for the actual prices, and a size of 30 by 8 for the predicted prices. This code calculates the root mean squared error, RMSE, between the predicted stock prices, stored in the prediction column, and the actual stock prices, stored in the actual column, of a stock. The RMSE is a metric that measures the average difference between the predicted and actual values, giving an indication of how well the prediction model performs. The calculated error value is then stored in the variable error. This code is related to stock prediction. The first line is a comment providing a link to a web page. The next three lines of code are used to print the lengths of three different variables, train_x, val_x, and test_x. It seems like these variables contain some data related to the stock prediction. By printing their lengths, the code is checking the number of data points in each of these variables. The code is accessing the shape attribute of a data frame called df. This attribute returns the dimensions, number of rows and columns, of the data frame. The code is using this attribute to retrieve and print the dimensions of the data frame. This code makes use of a function called forecast, which is used to predict future stock prices. It takes in two parameters, steps and xlog. The steps parameter determines the number of steps or periods into the future that the code will predict. In this case, it is set to 87, meaning the code will predict the stock prices for the next 87 periods. The xlog parameter represents any additional variables or data that may be used to make the prediction more accurate. In this case, it is set to test_x, suggesting that the code is using some test data as an additional factor in the prediction. Overall, this code is using the forecast function to predict future stock prices for a specified number of periods, taking into account any additional variables specified in the xlog parameter. This line of code checks the shape of the variable forecast_1. The shape function returns the dimensions of an array or matrix. In this case, it is likely being used to check the number of rows and columns in the forecast_1 variable. This code assigns the value of forecast_1 to a specific range of values in the train return column of a data frame called df. The range of values that are being assigned starts from index 906 and goes until the end of the train return column. This code is likely used in a stock prediction model to update the forecasted values in the data frame for future time periods. This code snippet is related to stock prediction. It is written in Python and utilizes a library called pandas. df.tail is a function call that operates on a pandas data frame object called df. The df.tail function returns the last few rows of the data frame, which represents the most recent data in this case. By calling this function, the program is displaying the most recent data of the stock or financial data stored in the data frame. This code is plotting the train returns and test returns data from a stock prediction model. The train returns data is shown in blue color on a graph with a size of 20 by 8. The test returns data as shown in red color on a separate graph with a larger size of 30 by 8.